Alright class, here's a video. Here's the objective 4.5. We're in unit 4 already. There's just one more. This is the last unit before the final. And this is objective 5. It's about linear inequalities. And the worksheet is worksheet 4.5. I don't remember if we have 24 questions, so I crossed this out. Just want to let you know, do the entire worksheet 4.5. Okay, we already started that in class. I helped you do some of them in class. Here are some other examples to help you understand a little bit more. Now, if you remember in class, we made we added a little box like this to our flashcard that we do with the formulas. Okay, and then we put the symbols inside it. I said sometimes we're going to do a solid line, the way we've been graphing lines. Sometimes we're going to have to do a dashed line, meaning it's like a discrete, the dots don't connect with each other. Okay, a dashed line. And sometimes you're going to shade below, and sometimes you're going to shade above the line. Okay, above the line. When am I going to do a solid line and shade below? Well, that's when I have a less than or equal to. When am I going to do a dash line and shade below? When I just have a less than. When am I going to do a solid line but shade above? When you have a greater than or equal to. And when am I going to do a dashed line but shade above? When I just have a greater than. So we'd add this little formula, it's like abbreviated notes to our formula sheets, so we can always have it right there in front of us to use it, okay? Now here is the notes we gave in class, you know. I said use your knowledge, let me fix it here. I said use your knowledge of graphing linear equations that we learned in Unit 3. Now linear equations was Unit 3. We learned about how to graph linear equations. We even created a formula sheet for the 3 forms of a line. So I want you to treat the inequalities, the linear inequalities, as if it was a linear equation. The rules are exactly the same. We still look for slope and y-intercept. We still look for x-intercept. We still graph exactly the same way. We just now have to shade above or shade below. Okay? And then we have to apply the rules of inequality. I'm going to graph like if it was a line, because it is a line, is linear. But I have to decide if I'm going to do a dashed line or a solid line, if I'm going to shade above or if I'm going to shade below. So, and that's why we created, instead of having in a written form this way, we created this nice little matrix or 2x2 box here to help us see in an easy way with visual. So I keep that by my side. Well, I don't need it anymore, but keep that by your side so as you're doing the homework, you can see how easy it is to graph this equation, these inequalities, okay? Like if it was a linear equation. So let's do a few examples. Take a look at this example right here. Example 1. This is the line that's giving me, okay? 2x plus 3y is greater than or equal to 12. Okay, most of these problems, almost all of them if I'm not wrong, it's going to be given to you in either of these 2 forms. It's either going to be ax plus by equals c, or it's going to give it to you as y equals mx plus b. If I see that is in this form, or I can put it in this form, I am going to look for the y-intercept, and I'm going to look for the slope, and I'm going to graph it. If you don't remember how to do that, go watch my video, graphing a line in the slope y-intercept form. Now, if it is given to me in this way, then all I have to do is find the x-intercept and the y-intercept. So that means I'm going to be making a little t-chart with x-intercept and y-intercept. So there's only this way right here or this way right here, okay? So when I look at this problem right here, when I look at this example, I say, the x and the y is on the same exact side. It must be the standard form. So I'm going to create a little t-chart right here on the side so I can find where does the line touch my x-axis and where does the line touch my y-axis. That's why we make the little t-chart. So x and y. If I plug in a 0 for x, I'm trying to find what is the value for y. I come over here and I say, well, 2 times 0 is 0. So this whole term disappears because 2 times 0 is 0. So this is gone. Then that means I just have to solve for y. If I divide it by 3 on both sides, because this is saying 3 times y, and the opposite of multiplying 3 times is dividing by 3. So if I divide by a positive 3, so I would have, if I plug in a 0 for x, it would be 2 times 0 plus 3 times y is greater or equal to 12. So the 2 times 0, it's gone, it's 0. I have a positive 3y is greater than 12. That means you divide by a positive 3 on both sides. And you get that y is greater or equal to a 4. And that's what we want, a 4. So I know that this line, I'm graphing it somewhere here, is going to be touching 0, 4. 0 for x, 4 for y, which would happen to be right here. Now if I know where it touched the x-axis, then I can connect those two dots. Let's find out where it touched the x-axis. That means I have to plug in a 0 for y so I can find out what is for x. Okay? So I grab exactly the same equation, 2x plus 3 times y, but I want y to be 0 is greater or equal to 12. Well, 3 times 0 is 0, so this is gone. So I just have 2x is greater or equal to 12. If you divide both sides by a positive 2, because this is saying 2 times x, and the opposite of multiplication is division, then I get x by itself is greater or equal to 6. There we go. Now I know that I should go to 6 for x, 0 for y. Well, this is 6 for x right here, okay? That's 5, that's 6. And 0 for y means I don't go up or down. There we go. All I have to do now is connect my two dots, but right before I connect them, I have to decide the rule of, I want to go ahead and connect them and make my line, if I was just doing a line. But I have to go check my rules of inequality, okay? Remember, I said take a look at your little box. And in your little box, if you look at it, I have a greater than or equal. That means greater than or equal is a solid line. See, it's a solid line, and I'm going to shade above. So this is a solid line. All right, it's a solid line, nice and long solid line with arrows at the end to point, saying that it goes forever. And I'm supposed to go ahead and shade above the line. Okay, above the line. Now, when I shade above, if I had a pencil, this would be nice and shaded here. If I'm shading above, what does that mean? Well, that means I can pick any point inside of the shaded area, even on the line, because the line is solid. So I can pick any point, this point right here, this point right here, anything in here, in the shaded area, any point I want in the shaded area. Doesn't matter, as long as it's in the shaded area. That means that if I plug in that point in my equation, it will give me a true statement. Okay, it will say a true statement. And true statements are something like 10 equals 10. Okay, that's a true statement. Or 10 is greater, well, let's do 15. 15 is greater or equal to 12. It is greater. It's not equal, but it is greater. Okay, so it will give you true statements. If you pick any point in here, it will give you a true statement. Let's go ahead and test the point. I'm just going to randomly pick something inside of the shaded area. It looks like 3 for x and 3 for y. This point right here, 3, 3. Okay? I'm just picking this point 3, 3. If I plug it in here, I'm picking the point, I'm testing the point 3, 3. If I plug it in my equation, it would be 2 times x, which is 3, plus 3 times y, which is also a 3. Is that greater or equal to 12? Well, 2 times 3 is 6, plus 3 times 3 is 9, and 6 plus 9, that's 15, and that it is greater than 12. Okay? So as you can see, the reason why we're shading, it's good to understand why am I shading. Well, because when I'm shading here, I'm telling you the solutions are all here to make this a true statement. Okay? So I can pick a point on the line because the line is solid. If the line was dashed, I would not pick a point on the dashed line. Okay, let's do another example. Here we go. Again, is either in standard form or in slope y-intercept. If the x's and the y's are on the same exact side, right here, then I have standard form. Okay, there's the only two ways to look at it. And you can use your formula sheet to see if you identify. This is in standard form. Here's my ax plus or minus by is greater than c. That's exactly what I see here. Okay, so that means I'm going to make a little t-chart. Okay, x and y. I'm going to plug in 0 for x and figure out what I get for y. If x is 0, then that means I have 0 minus 3y is greater than 6. Well, 0 is gone, okay? 0 minus anything doesn't change. Adding a 0 or subtracting a 0 from something doesn't change. I'm going to divide by -3 because I'm saying -3 times y. So that means I have to divide by -3 on both sides. So we can keep things even here. If I do it to the left, I have to do the same thing to the right. So a -3 divided by -3 is 1. So that is gone. I have 1y is greater than, and 6 divided by -3 is a -2. So my y value has to be greater than -2, right there. So I'm going to go to 0 for x, -2 for y, which is way down here. My grid, if I can show, would be 0, -2 would be right here, okay? There's my point. Okay, now let's go and let's solve it for if I plug in a 0 for y. Okay, so let's go back to our equation, and I'm going to solve it again, but this time I'm going to replace the y with the 0. So x minus 3 times 0 is greater than 6. Well, -3 times 0 is 0. Anything times 0 is 0, so that's gone. That means that x is greater than 6. So I'm going to go ahead and have a 6 here because I need x to be 6 or bigger, right? So if this is 5 right here, here is 6. All right, there we go. I want to go ahead and connect these two dots. But right before I connect these two dots, I have to decide if my line is going to be solid or is my line going to be dashed. Well, take a look at the symbol now. Doesn't matter, you just look at the symbol, and the symbol says greater than with no equal under. So that means I'm doing a dashed line. There is no equal, is a dashed line. So a little dashed line, just to show you, here we go, a dashed line, okay? Now I need to figure out where are my solutions going to be. Is it going to be more above or is it going to be below? Well, the sign says greater than, so I want to shade above. So I'm going to shade everywhere above here, lightly with the pencil. I would shade above here. So I can pick any point I want as long as it is above the line, the dashed line. I can pick 0, 0. I can pick 1, 0. I can pick 3, 4. Anything that's in a shaded area. But I cannot pick a point on the dashed line. Why? Well, because the dashed line is not included, okay? Hear what it says here. X minus 3 is greater than 6, not equal. So I don't want to count this line. If I wanted, I would have put an equal under and it would have been included the line, okay? So that equals means includes the line, and it does not equal, then it does not include the line. Okay, the dashed line is our boundary. We want everything above that line. All right, so let's do one more example. We did 2 of them in standard form. Let's take a look at a different one. We have y is less than or equal to 6. Now this doesn't fit any of the examples I gave you. It does not fit the ax plus by equals c, and it does not fit y equals mx plus b. Well, the students don't see it that it is one of these two, but when you start becoming really, really good at using these formulas, you will see, well, I kind of do have y equals mx plus b. I'm just missing the mx, okay? If I would spread this out, I could even rewrite this as y is less than or equal to, I am missing the mx plus the 6 is there, okay? So if I'm missing this mx, that means that it was a 0, okay? The slope must have been 0 times x. That's what it was, because 0 times x is 0, so it disappears, okay? 0 times x is 0, so it's gone. And most students just memorize that this is a horizontal line. The y-intercept is 6, okay? So this is still the y-intercept is 6. So you go up to 0 on x here. 1, 2, 3, 4, 5, 6. Here's my y-intercept. But the slope is 0, okay? The slope is 0. I don't go up, I don't go down, I just stay constant at the same 0 slope right here. So that is my line. Oops, I already drew it a solid line because I already saw it. It was an equal under, that means it includes, so I made a solid line, okay? It is a solid line because of the equal. And it's good to do these things in pencil, because if you do a solid line and like, oh, oops, it was supposed to be dashed, then you can go ahead and fix it and make it a dashed line. All right? So I know this is y equals 6, or y is less than or equals 6, is a horizontal line. Okay? I told the students before, long ago, this was a key concept, okay, that we learned long ago. Y equals any constant is a horizontal line. And x equals any constant is a vertical line. Okay, so if I have a y is greater than something or is less than something, that is a horizontal line. The slope is 0. And if it is x equals c or greater than c or less than c, is a vertical line, and the slope is undefined. So all I have to do now is decide, do I shade above or do I shade below? Well, I want all the y's, all the y values that are less than or including the 6. So I included the 6 line, and I want everything below because it's less than, okay? So the truth is you can pick anything here, any y value here is less than 6. 5 is less than 6, 4 is less than 6, any y value here is less than 6, okay? All right, so let's go ahead and do another problem. X is less than or equal to -1. So again, like I just told you a second ago, this is this concept of horizontal and vertical lines, and this is a x is less than or equal to a constant. When x is equal or less than or greater than a constant, we will have a vertical line. So that means I'm going to create my grid here. For some reason I didn't copy and paste a grid here already. So here's my x-axis, and here's my y-axis. So I know I'm supposed to do a vertical line. Where? At -1. So here's -1. Is it a solid or dashed? Well, I have an equal, so I want to include the -1. So it's going to be a vertical solid line right at -1. But I want all the x values that are less than -1, including the -1. So I want everything below here or to the left, okay? So we would shade everything here, and you would see that all the x's that are in this shaded area are less than -1. All right? So let's see if we have one more example, something a little bit different. There we go. So there are two special cases, vertical lines and horizontal lines. Or I look at which type of equation do I have here. Do I have the ax plus by equals c, or do I have y equals mx plus b? All right? It looks like I have almost this y equals mx plus b, which is the slope y-intercept form. But I need to get rid of this -3 right here, okay? Then I would have something nice. Well, then all we have to do is, this is saying -3 times y, and the opposite of multiplying by -3 is dividing by a -3. So x plus 9. All right, so I have to divide by this -3. So I would divide by a negative 3 here, divide by a negative 3 here, and divide by a negative 3 here. But there is a huge rule. That was a very important rule I wrote on the board in big letters. I said, if you divide or multiply by a negative number, you must flip the sign. Flip the sign. And this is not new. This is something that we learned, most of my students, 90% of them said, we learned this in 8th grade. Okay, so I know that flipping the sign because you're changing the values, it's something that we learned before. So I am dividing by a negative here, a negative 3. So I better change the sign. Negative 3 divided by negative 3 is a 1y, but I need to change the sign now. It's going to be less than. And I have a 1x divided by a negative 3. And a positive 9 divided by negative 3 is negative 3. Okay? A positive 9 divided by a negative 3 is a negative 3. So now I have things in the right form, and I am going to use this brand new equation. This is the brand new equation I'm using. I'm no longer referring to this other one. Okay? I switched it. I changed it to this. So I would go ahead and find my y-intercept is the letter b value, which is the number in the back, is negative 3. So I'm going to go to negative 3 for y, which it doesn't, I don't have a grid here to show this, but negative 3 would be down here. Negative 1, negative 2, negative 3 would be way down here if my grid kept on going. And then I'm going to find my slope, which is 1 over negative 3. So that means I'm going to drop 1 and run 3. It is not a positive slope. I'm not going up. I'm going down because it's a negative, okay? So from here at negative 3, I'm sorry that I didn't realize that the grid doesn't work for that. At here at negative 3, okay, that's negative 2, and that's negative 3. Here at negative 3, I would drop 1 more, and I would run 3 to the right. 1, 2, 3. And I would have my other dot right there, okay? So that's what you would have if you continue here with my grid. I'm sorry it didn't work out nicely there, okay? All right. So I dropped 1 more from my y-intercept, drop 1, and I ran 3 more. Now I would like to connect those 2 dots, but I have to see if I have a dashed or a solid line. It looks like we have a y is less than, not equal, so I have a dashed line. So I would go ahead and do my little dashed line connecting these 2 dots. Okay. All right. There we go. Just a little dashed line. And it says I want less than. So that means less than the dashed line. Then I would shade below, everything below the line. Less than the dashed line. So there we go. Unfortunately, when I copied and pasted the grid, I didn't realize that we were going to have a something that was going to actually go to the negative spot over here. I'm sorry, I apologize for making this mess over here, but it is something way below here, okay? The y-intercept is negative 3, and we dropped 1 and we ran 3 because our slope was negative, all right? So hopefully this helps you understand. Sometimes I look for the y-intercept and the slope. Sometimes I look for the x and the y-intercept. I do the little t-table. So there's the only two ways to go. Here, in this cases, most of your homework, almost all of them, are exactly like these 4 cases I have done here. Okay? So good luck with your homework. Attend Math Lab or come and ask me for help. All right? Good luck.